Now we're going for the second part, which is saying to us one person leaves the group and the mean one person leaves the group. So I'm going to underline that. That's important. Okay. Mean age of the remaining 17 people is exactly 41 years. All right. So mean age of 17 people is 41. Find the age of the person who left and standard deviation of the ages of the remaining 17. So first one, there are two questions here, okay? First is find the age of the person who left, and the second one says the standard deviation of the ages of the remaining 17. All right, so now I go to second part. I've been told that the mean of 17 people is exactly 41 years. Now we are trying to, so we know the mean. Now we know what the mean was for 18, right? We know what the mean was. It was 41.4. All right. So now, well, how would we get the mean for 17 people? Would say mean is equal to the sum of x over n would be 17 this time, right? It'll be over 17. Do we have that? Do we have the sum? We don't, but we know the mean. So we can put 41 is equal to the sum. Is it 41? Yeah. 41 is equal to the sum of x over 17. And I can now say 41 times 17 is equal to the sum of x. I'm trying to find what is the sum of 17 people, because I know the sum of 18. And if I can get the sum of 17, I'll say sum of 18 minus sum of 17 will give me what 1 would be. So I'll now say 41 times 17. It'll give me 697. So 697 is the sum of 17 people. So I now have 17 after one person has left, and my sum is 697. What was my sum when this person was there? My sum was 745. So I can say that sum of 17 is 697. Sum of 18 values would be, is it 745? Yeah, it is 745. 745. So I can now say x will be equal to summation of 18 minus the sum of 17. Then I can find what the 18th one would be. So it's going to be 745. 745 minus 697. So I can put that. I can say 745 minus 697. I'll get 48. So that means the person that left was 48 years. Okay. Now I can do the second part, which says find the standard deviation of the ages. So here I can find the standard deviation. I can say standard deviation is the square root of x squared over n, the sum of x squared over n minus x bar o squared, right? And what is it? Do I have the sum of x squared? This is now something very interesting, okay? Because what do I know? I know that I had the sum of x squared for 18 people, right? Now I can have the sum of x squared for me to be able to do this formula. I can say that I have the sum of x squared for 18 people. And this was, let's go back to the original one. It was 33,951. So it was 33,951. Now, what is the sum of x squared of 17? How do I get the sum of x squared of 17? It is 33,951 minus this 18th person minus 48 squared. Okay, it's like I'm removing this one. So that's what I do, and I can be able to get it, right? So I'm going to say 33,951 minus 48 all squared. I'll get 31,647. That's my new solution. This is the sum of x squared for 17. And now I can say that standard deviation is equal to square root of summation of x squared for 17 all over 17 minus x bar squared, which is going to be, what's the sum? 31,647 all over 17 minus, what's the mean? I've been told the mean was 41 exactly. Yeah, it was 41. then I can say 41 should be squared. Don't forget to square it. Is going to be now, I'll say 31,647 divided by 17. I'll get an answer. Then I'll say minus 41 squared. Then I'll say square root, and I'll get 13.43, blah, 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 which is just going to be 13.4 to 3SF. And this is going to be your final solution. And did we answer every question? I believe so. Yeah, I found it. So I believe we've answered everything. I shouldn't call it II, but I should just leave it like that. Maybe call it part B. This is sorry. This is part II is true. And then let's see. This is no longer II. This is B. And this is A of II. Now we are done. This is it. If you know this, then you're strong. Now, because this was a past paper question from the Cambridge paper 6. It used to be paper 6 then, from November 2004. Okay, you can go and check question number 4. This is where this question got derived from. And you're done. If you know this, well done. Bye.